This problem, a is a constant. For what values of a will this series converge? So notice that this part right here makes it alternate positive, negative, positive, negative. It's starting at n equals 1, which means that it would start with negative 1 to the 0, so it starts positive. So having an n minus 1 up there, it just switches it. Instead of going negative, positive, negative, positive, this one's going to go positive, negative, positive, negative. It's still alternating. So that's not really the important part. The important part is that it's got 1 over n to the a. So this one really is of the form, it's got the alternating part, but then it's got 1 over n to the a. And for what values of a will this converge? So there's two parts to the alternating series test. One is you have to take the limit of this thing as n goes to infinity. And the answer to that has to be 0. So are there any values of a that would stop that from happening? So if you had, for example, that a was a 1, it would just look like this. 1 over n as n goes to infinity. So 1 divided by infinity, that's 0. And if n was a 0.5, let's say, if n was a 0.5, then we would be looking at 0.5 means a half. That means the square root of n. So then we would have n going to infinity. The square root of infinity is infinity. 1 divided by infinity is 0. So you can even have fractions that are less than 1. What about if it was squared? Well, again, infinity squared, that's infinity, so you're dividing by infinity. 1 divided by infinity, that goes to 0. So far, everything's going to 0. But I've only chosen positive numbers so far. What if you chose 0, which is neither positive or negative? Well, how much is n to the 0? That's going to be 1. So that means you're going to have 1 over 1. That's not equal to 0. So a cannot be a 0. What about a negative? Well, then this actually means invert it, which means you have n. And then if n is going to infinity, this is going to infinity. So this does not work, and this does not work, but these do. So 0 does not work, negative does not work, positive does. So one restriction is that a has to be positive. Then on to the second part of the alternating series test, which says that this sequence needs to get smaller and smaller and smaller. In other words, if you go to the n plus first term, and you compare that with the one that was before it, which was the nth term, this has to be getting smaller. So then, when will this be true? For what values of a is this true? Well, we could do some algebra here. You could invert both sides. When you do that, it's going to invert the inequality as well. You could even take the a root. It's not easy to say. The eighth root. The eighth root. It almost sounds like I'm saying eighth, but the eighth root of both sides. And then, when is n plus 1 bigger than n? Well, if you add 1 to something, that makes it bigger. So, that's always true. And so, it passes that. So the real restriction is that a has to be positive.